Researchers at Aalto University have announced that they have developed an optical chirality logic gate that operates about 1,000,000 times faster than existing technologies. This is important research that shows the possibility of leading to the realization of ultra-high-speed processing in next-generation computing. The processors installed in the PCs and smartphones that we usually use are composed of logic gates. This represents the two values 0 and 1, which are digital calculations in computers. And the latest processors perform enormous calculations by combining billions of these logic gates. To meet next-generation data processing needs, such as AI dataset evaluation and algorithmic inference sourcing, computing logic gates will continue to get faster. The processors installed in conventional computers operated electronically by shuffling electrons, but electronic control is expected to reach its limits sooner or later, and scientists are working to develop next-generation systems. Optical logic gates are developed using photons to meet the demands of data processing and transfer in computing. Researchers at Aalto University say they have succeeded in miniaturizing this with a new approach. Optical computers have been built before, but they required complex hardware and were limited to specific applications. According to Zhang, the new gate can be made from a single layer of molybdenum disulfide crystals, just 0.65 nanometers thick using existing manufacturing techniques, and is designed to perform universal tasks in a small package. Chirality is important in the approach that the team uses to achieve this extremely fast processing. Chirality refers to the property of molecules and objects that have two mirror image forms, such as our right and left hands. When a light beam forms a helical wavefront, it is polarized leftward or rightward, resulting in a chiral state, and this property was used in this study. In the experiment, the direction of rotation of the circularly polarized beam is controlled through a crystal material sensitive to the circularly polarized beam. The direction of rotation of the light beam is determined by the shape of the crystal through which it is bent, either clockwise or counterclockwise. In optical chirality logic gates, the clockwise or counterclockwise direction of the light beam determines the logic function. Then, by constructing these gates using optical filters or the like, conventional gates can be reproduced. The research team demonstrated working optical gates that mimic traditional logic gates called XNOR, NOR, and XOR, OR, and NAND, all of which perform different operations on data. These operations can be performed in parallel rather than serially, potentially opening avenues for significant improvements in computational efficiency and speed. This multifunction logic gate further evolves the electronic logic gate, and it is possible to realize multifunction logic circuits that are more advanced and complex than those at present. An all-optical computer's biggest advantage is that optical chips are superfast compared to conventional chips. Also, electronic devices can be resistive. Light has the ability to parallelize and consumes less energy.